A sweeping aerial shot of the Earth fills the screen. Blue oceans, swirling white clouds, vast stretches of green and brown. The narrator's voice begins softly contemplative. Everything that lives on this planet depends on food. From the smallest plankton in the sea to the billions of people who sit down to eat every day, life runs on energy captured long ago from sunlight and air. The camera glides closer to show crops rippling in the wind, herds of cattle, farmers tending fields. For thousands of years we've drawn our nourishment from the soil beneath our feet. But what if the next revolution in food doesn't come from the ground at all? What if it comes from the air itself, cut to the hum of city traffic and a skyline hazy with smog? As the world's population grows, our need for food grows with it. By mid-century, nearly 10 billion people will share this planet, each depending on systems already stretched thin. Droughts, floods, deforestation, and declining soil fertility threaten harvests. Our diets rely heavily on agriculture that consumes vast amounts of water and land. Producing a single kilogram of beef can take 15,000 litres of water. Even plant crops depend on fertile soil and predictable seasons, both increasingly unstable. Images of parched earth, shrinking rivers and burning forests flash by. We can't keep expanding farmland forever, so scientists are asking a radical question: can we make food without farming? Inside a futuristic laboratory, stainless steel bioreactors glow with faint blue light. Tubes carry clear liquids and gases. Researchers in white coats monitor digital screens. The narrator continues. It sounds like science fiction, food made from air. But behind these walls, that idea is becoming real. Using only carbon dioxide from the atmosphere, water, minerals, and renewable electricity, scientists are learning to grow edible protein using microorganisms. No soil, no sunlight, no crops, just the basic elements of life transformed through science. The camera pans across a reactor labeled air protein. A scientist explains while pouring a fine yellowish flour into a bowl. These microbes feed on a mix of hydrogen, oxygen, carbon dioxide, and nitrogen, the narrator explains. As they grow, they produce protein rich in amino acids, vitamins, and minerals. The result looks like flour but can be shaped into meat, dairy, or pasta. The scientist smiles, holding up a patty sizzling in a pan. They call it air-based meat because, quite literally, it's made from the air around us. The scene shifts to a lush finished landscape under a midnight sun. In another corner of the world, a company called Solar Foods has created something called soline, a golden powder produced by bacteria that eat carbon dioxide and hydrogen. In a small reactor near Helsinki, this process happens entirely indoors, powered by renewable energy. There are no fields, no pesticides, no animal waste. The microbes multiply within days, and when harvested, their biomass becomes a fine powder that is 65% protein. We see a chef in a test kitchen mixing the powder into dough. A bread, pasta, even ice cream, all made using a protein born from thin air, cut to microscopic imagery of bacteria dividing rapidly. How does this actually work? The narrator asks. The voice slows, explanatory. It begins with capturing the elements of air. Carbon dioxide is pulled from the atmosphere, nitrogen and oxygen are separated, water is added, and electricity, ideally from solar or wind, provides energy. Through electrolysis, water is split into hydrogen and oxygen. Microbes use hydrogen as fuel and carbon dioxide as carbon source. They grow, multiply, and create biomass rich in protein, fats, and carbohydrates. When the culture matures, it's harvested, dried, and turned into an ingredient that can be used in food manufacturing. In times of crisis, droughts, floods, war, such systems could provide lifelines. The scene shifts to a conversation between two scientists. It's not about replacing agriculture. One says it's about adding resilience. The other nods and giving people choice. As the documentary nears its close, we return to the narrator standing before a glowing bioreactor. But could we really make food from air? The answer is yes. In fact, we already are. The first powders have been made, the first meals eaten. The challenge now is to scale, to make it affordable, accessible, and desirable. They pick up a small spoon of golden powder. Inside this lies the future of food, built not on ploughs and fields, but on electrons, microbes, and imagination. The camera slowly rises toward the ceiling lights, then dissolves into a time-lapse of clouds drifting across a bright blue sky. The air around us holds the building blocks of life: carbon, hydrogen, nitrogen, oxygen. With these elements and a spark of energy, nature has always made food through photosynthesis. Now humanity is learning to do the same in our own way. Perhaps the next green revolution won't happen in the fields, but in the air. Soft music swells as the scene transitions to people sharing a meal. A family at dinner, students in a cafeteria, astronauts floating in space with packaged meals, a woman in Karachi tasting a biscuit made from air protein flour. The narrator's final words echo as the camera pans out toward the horizon. From air to sustenance, from imagination to reality, the story of food has always been the story of life finding a way Today we stand at the beginning of a new chapter, one where the sky itself might feed us, one where the invisible becomes nourishment, one where quite literally we learn to eat the air.